2024 A-Level Combined Mathematics Paper 1, Part B, question number 12, Part B. Part A of the same question was discussed in a previous video, link in the top right. Part B of this question has to do with the sums of finite and infinite series. The question says, let u of r be equal to 1 over r times r plus 2 times r plus 4, and let f of r be equal to 1 over r times r plus 2 for r element of the positive integers. Given this, we are asked to then determine the real value of the constant a such that f of r minus f of r plus 2 is equal to a times u of r for all r element of the positive integers. Now after we do this and we find the value of a such that f of r minus f of r plus 2 is equal to a times u of r, we are then asked to hence show that the sum from r equals 1 up to r equals n of u of r terms is equal to 11 over 96 minus 1 over 4 times n plus 1 times n plus 3 minus 1 over 4 times n plus 2 times n plus 4 for n elements of the positive integers. We are then asked to show further that the infinite series of all of the infinite terms from r equals 1 up to infinity for r equals 1, 2, 3, 4 and so on of u of r terms, all of them added together, is convergent, meaning it's not infinite or some undeterminable value, it is instead a constant, and we are asked to find that value of the sum. After this, we are finally asked to find the value of the real constant m such that if you take the limit as n approaches infinity of the sum from r equals 1 up to n of m times u of r plus u of n plus 1 minus r terms, if you take the sum of all of those from r equals 1 up to n as n approaches infinity, you need to find the value of m such that this entire sum gets closer and closer to 11 over 32, which we can see is curiously equal to 3 times what we have here. So, to start off this question, let's first off try to use u of r, which is this value, and f of r, which is this value, to form this equation and see what the value of a should be in order for both sides to be equal. So in our answer sheet, we're going to start by writing let u of r be equal to 1 over r times r plus 2 times r plus 4. And the reason we're doing this is because in our answer sheet, we cannot quickly see what f of r and u of r are equal to, since it is separate from our question paper. Due to that, I'll quickly rewrite them. F of r is equal to 1 over r times r plus 2 for r element of positive integers. Now, given this, we're going to say consider f of r minus f of r plus 2 being equal to a times u of r, where a is an element of the real numbers. Considering this, if we take the left hand side, we take LHS and take it forward, f of r minus f of r plus 2 can be substituted by substituting the values into this expression right here. So we can see f of r is just 1 over r times r plus 2, but f of r plus 2, what we have to do is to take the values of r here and replace all of them with r plus 2's. So therefore this becomes r plus 2, and then here we have r plus 2 plus another 2, which is going to be r plus 4, and therefore f of r plus 2 is equal to 1 over r plus 2 times r plus 4. Now, considering this, we can see we could take all of this under a common denominator of r times r plus 2 times r plus 4, which is required in order to get a u of r term. And we can see if we do that, we're going to get equal sign here, and then to get the top and bottom being multiplied by r plus 4 here, we're going to have r plus 4 on top, and then we're going to have a common denominator of r times r plus 2 times r plus 4, and for the other term, we can see to get the common denominator, we need to multiply top and bottom by r, meaning that we get r here divided by r times r plus 2 times r plus 4. So therefore we have minus r on top, so minus r. Now we can see if we cancel this and this, we're going to be left with 4 divided by r times r plus 2 times r plus 4. And we can see if we factor out the 4, we're going to get 4 times 1 divided by r times r plus 2 times r plus 4. And we can see this is exactly equal to 4 times u of r, since this term right here is exactly what u of r is. So we can see, considering the LHS, we go to the RHS, where we have 4 times u of r, but we expected a times u of r, and therefore we can see, according to this, therefore a must be equal to this value here, which is 4. So therefore a is equal to 4, and therefore f of r minus f of r plus 2 is equal to 4 u of r. Or alternatively, since in the next part of the question we need to find the sum of u of r terms, we could rearrange this and write that u of r is equal to 1/4 of f of r minus f of r plus 2. And in fact, this is what I'm going to write as my final statement based on the fact that a is equal to 4. Now after this, moving on to the next part of the question, we are asked to hence show that the sum from r equals 1 up to n of u of r is equal to all of this. Now to do this, what we're going to do is to consider the values of u of r and then use the substitution that u of r is equal to 1/4 of f of r minus f of r plus 2, and when we do this, we will see that the sum we get is a telescoping sum, meaning that the terms in the middle cancel out and we're left with only a few terms at the start and a few terms at the end. So if we try and see what that's going to be equal to, what we need to do is to consider the sum of u of r terms from r equals 1 up to n. So we're going to go down here and we're going to say, consider, we'll go to the actual next page to start off with a fresh page, and we'll say sum r equals 1 up to n of u of r, and we can see, since each individual u of r term is equal to 1/4 times f of r minus f of r plus 2, the sums must also be equal, and therefore the sum from r equals 1 up to r equals n of u of r must be equal to the sum from r equals 1 up to r equals n of 1/4, which I can actually take out, of f of r minus f of r plus 2. And therefore we can see on the left hand side we have the sum that we want, on the right hand side we have something else that is going to create a telescoping sum. Now to solve this, what we have to do is to consider different values of r and just write down a few terms, and then we'll see when we write down a few terms that some of these terms are cancelling out. So what I'm going to do, I'm going to write the first few terms of r equals 1, r equals 2, r equals 3, and actually that's enough for now. We can write down the first few terms and then we can draw a couple of dots to say that there are some in between terms. I'm going to draw a couple of dots like this, and then let's draw the last few terms. So the very last term is the r equals n term. Before that we have the r equals n minus 1 term, and before that we have the r equals n minus 2 term. Since I do the last, or rather since I do the first 3 terms, I'll also draw the last 3 terms. So therefore we have r equals n minus 2, r equals n minus 1, and finally r equals n. And these are the terms that we're considering. Now, considering these terms, if we look at this equation that we have here, on the left hand side we have u of r terms. So therefore for r equals 1 we have u of 1, for r equals 2 we have u of 2, r equals 3 u of 3, so on and so forth. Over here we have u of n minus 2, u of n minus 1, and u of n. So these are the terms that we have on the left hand side of this equation here. Now considering the right hand side, we can see if we draw a bunch of equal signs like this, this and this, and this, this and this. For the first term we have r equals 1, meaning we have r equals 1 in here substituted times 1/4, which is going to be 1/4 of f of 1 minus f of r plus 2, which is 1 plus 2, which is 3. So therefore f of 1 minus f of 3. Now considering the next one, we have 1/4 of r equals 2, which is going to mean we have f of 2 minus f of 2 plus 2, which is f of 4. The next term of that is 1/4 of f of 3 minus f of 5. And it continues like that, so on and so forth. So it goes down like that all the way until the last terms, and for the last terms we have 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, and here we have 1/4 of f of r minus f of r plus 2, where r is equal to n minus 2. So therefore we have f of n minus 2 minus f of n minus 2, which is r plus 2, when the minus 2 and plus 2 cancel, giving us f of n. So therefore we have minus f of n. Now for the next term we have f of n minus 1, and here we have f of n minus 1 plus 2, which is f of n plus 1. Now finally we have f of n here, and then minus f of n plus 2. And that is all we have for this sum. Now, considering the terms on the left hand side, the terms on the left hand side are simply the sum from r equals 1 up to n of u of r. But if you consider terms on the right hand side, you can see here we have a minus f of 3. Here we have a plus f of 3. The plus f of 3 and the minus f of 3 will cancel and they will go away. Now similarly, in the next term you can see we have f of 4 here. We would have a f of 4 here. This is minus f of 4, this is plus f of 4, and therefore this would cancel for that, and so on and so forth downward, and that would continue all the way until the very last terms. Now considering the very last terms, we can see here we have f of n, here we have minus f of n. Cancelling them out, we would get nothing there. Similarly, in the previous term, here we'd have minus f of n minus 1, here we have plus f of n minus 1, those two cancel and so on upward. So we can see this diagonal cancellation goes all the way down from the top and all the way up from the bottom, and what we're left with is 1/4 of f of 1, 1/4 of f of 2, and 1/4 of negative f of n plus 1, and 1/4 of negative f of n plus 2. So according to that, we have 1/4 of f of 1 plus f of 2 minus f of n plus 1 minus f of n plus 2. And now we can see this sum has turned into a telescoping sum because all we have here is the first few terms and the first, or rather the last few terms. So because of this, we can see all the stuff in the middle cancels and we have telescoping sum. We have the first two terms and the last two terms. Now, what we need to do in order to obtain the expression that we have in the question, that is this expression right here, is to simply substitute in f of r as 1 over r times r plus 2. Now, if we do that, we can see we're going to get 1/4 of, and here we have f of 1, which is 1 over 1 times 1 plus 2, which is 3, and f of 2, which is 1 over 2 times 2 plus 2, which is 1 over 8. So we have 1 over 8 here, 1 over 3 here, and then we have minus 1 over r, which is n plus 1, times r plus 2, which is going to be n plus 3 here. For the next one, we have minus 1 over, and then we have n plus 2, which is r, and n plus 2 plus 2, which is n plus 4 over here. So we have this. Now, considering this, we can distribute the 1/4 here, and we're going to get, we'll ignore this part for now, go to this part and have 1 over negative 1 over 4 times n plus 1 times n plus 3, and minus 1 over 4 times n plus 2 times n plus 4. Now, going back to these terms, we can see here we're going to have 1/3, here we're going to have 1/8, and the common denominator here is 24, and if we do that, we're going to have 1/3 plus 1/8, which is going to be equal to 8 over 24 plus 3 over 24, which is going to be equal to 11 over 24. So we have 11 over 24, but then we have to multiply by 1/4, and if we multiply 24 by 4, we get 96, and therefore we have 96. On top we have 11, so the term here is 11 over 96, and therefore we have 11 over 96 minus this term, and that is the value of our sum. So according to this, we can see our sum sigma r equals 1 up to r equals n of u of r terms is equal to this expression right here. So we can say as a finale that the sum sigma r equals 1 up to n of u of r is equal to 11 over 96 minus 1 over 4 times n plus 1 times n plus 3 minus 1 over 4 times n plus 2 times n plus 4. And that is our answer to this part of the question. Now, moving on from that, the next thing they asked us to do is to show further that the infinite series from r equals 1 up to infinity of u of r is convergent and to find its sum. Now, since we already have an expression for the value of the sum from r equals 1 up to n, all we need to do in order to find the sum from r equals 1 up to infinity, or the infinite sum, is to simply take the limit of this expression as n approaches infinity. So what we can do is say the sum from r equals 1 up to infinity for integer values, of course, of u of r is equal to the limit as n approaches infinity of the sum of terms from r equals 1 up to n of u of r, which is equal to the limit as n approaches infinity of the expression for this sum, which is this expression right here. So all we have to do is to substitute this expression into the limit, simplify, and see what we get. So we get 11 over 96 minus 1 over 4 times n plus 1 times n plus 3 minus 1 over 4 times n plus 2 times n plus 4. So this is what we have. Now considering this, we can see if we take the limit as n approaches infinity, the very first term is a constant, so it will remain. So we have 11 over 96. Now considering the next term is 1 over some powers of n that are positive. Due to this, when we take the limit as n approaches infinity, this term is going to diverge to infinity, meaning that 1 over that term is going to approach 0. Therefore, this term right here approaches 0. Similarly, the second term here also approaches 0. Now we could prove this formally, but for now, since this is a very small part of the question, we can just directly say, since the powers of n on the denominator are greater than the numerator, or the order is negative of the overall thing that we have here, we can see we're going to approach 0 as we take the limit as n approaches infinity. So therefore this term also becomes 0. Due to this, we have 11 over 96 minus 0, which is equal to 11 over 96. So therefore, our sum up to infinity of u of r terms approaches a constant, and the constant value it approaches is 11 over 96. Now, since this wasn't some infinity or a divergent value that doesn't converge to anything, but instead it was actually a constant term, we can say, therefore, the sum from r equals 1 up to infinity of u of r converges, because it didn't diverge, it converged to a certain value, and we can say its sum is 11 over 96. So we can see it did not diverge, it instead converges, and it converges to the value 11 over 96. Now after this, the final part of the question says we have to find the value of the real constant m such that the limit as n approaches infinity of the sum from r equals 1 up to r equals n of m times u of r plus u of n plus 1 minus r is equal to 11 over 32. Now, going down, if we write this, we can see we have to show that the limit, actually not show that, we have to find the value of m such that the limit as n approaches infinity of the sum from r equals 1 up to n of m times u of r plus u of n plus 1 minus r is equal to 11 over 32. Now, what we're going to do in order to solve this is to use the sum rules to break this sum into pieces that we know how to find. So what we're going to do is to first break this sum into these two pieces of m times u of r and u of n plus 1 minus r. So we can write this as the limit as n approaches infinity of the first sum, which is the sum from r equals 1 up to n of m times u of r plus, and then we're going to break the second part as the limit as n approaches infinity of the sum from r equals 1 up to n of u of n plus 1 minus r, and that is equal to 11 over 32. Now, there is a special trick that we need to do for this sum right here. So for now, I'm going to break for a second and go to the special trick that we have here. So what we're going to do is to consider the sum from r equals 1 up to n of u of n plus 1 minus r. Now considering this sum, the sum from r equals 1 up to n of u of n plus 1 minus r can be found if we simply consider substituting different values of r into here. So for the first value r equals 1, we can see we have u of n plus 1 minus 1, which is u of n. For the second term, we have r equals 2, which is going to be u of n plus 1 minus 2, which is going to be u of n minus 1. The next term would be u of n minus 2 and so on. And if we consider last terms, as we approach r equals n, for r equals n minus 2, we are going to have plus u of n plus 1 minus n minus 2, which is going to be u of 3. Since we have plus 1 here and minus 2 there, we are going to have plus 3. Now the next term is going to be u of 2, since we have n plus 1 minus, and then we have n minus 1, which is going to be equal to u of 2. And finally, we'd have r equals n, which is going to result in u of n plus 1 minus n, which is u of 1. We have this. Now, taking a look at this sum, we can see we have all the terms from u of 1 up to u of n in order here, but we can see the only difference is the order is reversed. This sum is exactly the same as the sum from r equals 1 up to n of simply u of r. Both of those sums are the exact same because they have the same exact terms. It's just that the terms in here are in reverse order. So we can see, since that doesn't really matter for the overall sum, we can write this as being equal to the sum from r equals 1 up to n of u of r. And therefore, if we go up and substitute, we can see in this sum, we could replace this sum with the sum from r equals 1 up to n of simply u of r. Now when we do that, I'm also going to do another step. I'm going to take the factor m here out of this sum, out of the sigma, and also out of the limit, since we can take a constant factor m, or any constant rather, out of a sum and also out of limit. So therefore I'm going to use this fact and I'm going to say m times the limit of the sum of u of r. So I'm going to say m times the limit as n approaches infinity of the sum from r equals 1 up to n of u of r plus, and then the second term here is the limit as n approaches infinity of the sum from r equals 1 up to n of just u of r. So I'm going to write limit as n approaches infinity of the sum from r equals 1 up to n of just u of r is equal to, and on the right side we have 11 over 32. 11 over 32. Now here we can see we have m times this value and that same value here, and as we know, the limit as n approaches infinity of the sum from r equals 1 up to n of u of r is equal to 11 over 96. So what I can do is to directly substitute in 11 over 96 here and plus 11 over 96 here, since this limit of this sum is equal to 11 over 96, and that is equal to 11 over 32. Now here we can see if we divide everything by 11 over 96, we're going to have m plus 1 here, and here if we divide, we're going to have 96 over 32 finally, and 96 over 32 is equal to 3. So therefore we have m plus 1 equal to 3. From this we can see that m must be equal to 2, and that is the final answer of this question. So now finally that we finish this question, let's discuss the marks order for this question. So at the start of the question, when you take this equation f of r minus f of r plus 2 equal to a times u of r, and then you substitute the left hand side for f of r and f of r plus 2 like so, you get 5 marks for that. After this, when you take both of them under a common denominator of r times r plus 2 times r plus 4, and then you take this expression right here, you get 5 marks. When you simplify it and you see if you take a 4 out, you get 4 times u of r, you get 5 marks. And then when you finally use that to conclude that a must be equal to 4, you get another 5 marks. Now after this, for the next part of the question, when you want to find the sum from r equals 1 up to r equals n of u of r, when you write out the sum considering the r equals 1, r equals 2, r equals 3 and so on, and r equals n minus 2, n minus 1 and n values, and then you write out each of their corresponding equations, for the first 3 equations at least you get 5 marks, and for the last 3 equations at least you get 5 marks. You can write more than that. You can write maybe r equals 4 here and r equals n minus 3 here, but they at minimum want you to write 3 at the start and 3 at the end. Now after getting those 5 marks and 5 marks for that, when you see that most of the terms in the middle cancel, and then you write out the equation for the sum from r equals 1 up to n of u of r in terms of only the terms that survive, like so, this gets you 10 marks. When you then substitute in the values of f of 1, f of 2, f of n plus 1 and f of n plus 2 like this, that gets you another 10 marks. And when you simplify that down to the final answer of the expression that they had given in the question like this, that gets you another 5 marks. Now after this, for the next part of the question, when you are asked to test for the convergence, when you write down that the sum from r equals 1 up to infinity of u of r is simply the limit as n approaches infinity of the sum from r equals 1 up to n of u of r, and then you apply the limit to the expression obtained for the sum from r equals 1 up to n of u of r like so, doing this gets you 5 marks. Now when you apply the limit and you get the final answer of 11 over 96, that gets you another 5 marks. And interestingly, when you then write the conclusion sentence saying that the sum from r equals 1 up to infinity of u of r converges and its sum is 11 over 96, for writing this sentence after finding the sum, you get another 5 marks. So basically, you write the same exact thing again with the statement that the sum converges and the sum is 11 over 96. That statement gets you another 5 marks. So it's very important that you write the statement in addition to finding the actual convergent value. Now after this, for the next part of the question where you have to find m, when you write out this expression, do some simplifications, and then you simplify the sum from r equals 1 up to n of u of n plus 1 minus r into the sum from r equals 1 up to n of u of r, which is a crucial step in this calculation that we have here. For that, you get a total of 10 marks for the logical step that you have. After this, when you then get an expression that looks like this, where you have the limit of n approaches infinity of the sum from r equals 1 up to n of u of r terms, and then you substitute the previous value of 11 over 96 into here and here. For the substitution, you get another 5 marks. Now finally, when you rearrange, divide and simplify, and you get m plus 1 equals 3, leading to m equals 2, and you write down m equals 2, you get another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.